Hello, hello, hello. How's everybody doing out there in algebra land? We're going to jump right on into our lovely, lovely logarithmics day, because our goal today is to evaluate those logs and write the exponential and logarithmic equations. So what is a exponential function? That's y is equal to b to the x, where b cannot equal 0, as we talked about in the previous video. If you need more info on that, go ahead and go back and click the previous video. What we're going to do today is really get into this logarithmic function. So the way that's going to look is log base b of x. So, ladies and gents, there's some big differences, okay? And the first thing I want you to remember is that this is going to be, the log is going to be an inverse of your exponential function. So this was something that you guys did right, right as you got close to spring break. So it's been a while, but the big thing that students usually have success with is when they think of logs in terms of exponents, which in case sometimes just means converting it. So some teachers like to use left to right equals the middle, okay? Another student or another teacher will use the loop-de-loop. And then a personal favorite of mine, the one I like to use, is that your base stays base and the other two switch place. So I would talk to each individual trig teacher and decide which method works best for them and go from there. So the first thing we're going to do is we're going to try to get in the feel of our exponential form. So let's go ahead and take a look at number one, okay? So, ladies and gentlemen, boys and girls, it says that log, and then this is supposed to be a base 2, so I'm just going to write base 2, of 8, obviously equals 3. So we're going to convert this to an exponent form, but really, really quickly, I just want you to go back over this really quickly. What this means is that your base is going to be 2. So just like a base of an exponent, that's the base is what you're going to be multiplying by itself, okay? So we're going to say, hey, I have a base of 2, and then when all is said and done, this is the answer I get, which is 8. And then how many times do I have to multiply myself? 3. So I like to think of it, ladies and gentlemen, if I could erase this just for a moment, is I say, how do I go using exponents from 2 to 8? So this is not times 4. This is not plus 6. This is obviously using exponents. So how do I go from 2 to 8? And we'll use this concept many times throughout our video today. 3. So 2 to the 3 is equal to 8. So let's go ahead and talk a little bit about those phrases that we talked about at the front. So the first one I'm going to start with is my favorite. The base stays base, the other two switch place. So when I say that, I'm going to erase this log really quickly. Imagine me covering this up with my hand. So I would say, hey, this is a 2. That's kind of looks like 2 to the 8th, which is an exponent. So the base, which is a 2, stays the base. And the other two switch place. So this is 2 to the 3, and then this goes on the other spot. So that's base stays base, the other two switch place. Alrighty. The other one is the loop-de-loop. So loop, loop. So that's how it's 2 to the 3 is equal to 8. Okay? And then, ladies and gents, the other one is left to right equals the middle. Okay? So left to the right, as in 2 to the right, as an exponent, equals the middle number 8. So however you want to write that, however you want to think about it converting wise, is up to you. Base same as base, loop to loop, left to the right equals middle. But all in all, 2 cubed is 8. Because remember, this is all exponents. That's one of the things that students have the toughest time is what is a logarithm? A logarithm is a operation that says, how do I get to another number using exponents? Okay? So let's go to number 2. Now, number 2 is tricky, and let's see why. There's no base. So there's no written base. When there's no written base, that is an implied 10. So if you see no base, I want you to write a 10. So let's rewrite this. So log base 10 of 10 is equal to 1. So let's think about this. 10 to what power gives you 1? Well, 10 to the first power gives you 10, because anything to the 1 power is going to stay that number, okay? Or, again, base stays base, the other two switch place. However you want to write it, you're good to go. Or however you want to say it, I want to say. All right, let's look at this next one. 16 to a 4. Well, you're getting smaller. And so I want you to note that we're getting smaller here. So the idea is that it's got to be a fraction, hence why 16 to the 1/2 is equal to 4. All righty. Now, let's go ahead and make sure we're good with this. Remember, anytime you see a fraction, that's really a radical or a root, okay? So when you have a x to the ab, let's just write that really quickly so we have that. That's like saying the b root of x to the a. Cool? All right, so base stays base, the other two switch place. Left to right equals the middle, loop de loop. However you want to think about it, talk to your teacher to see what you like best. All righty. So ln of e. So this is important. So whenever you see an ln, that's the same thing as log base e. So log base e of e is equal to 1. Well, we already talked about this with the tens over here. How do you go from 10 to 10? How do you go from e to e? Well, it's the same thing. E to the 1 is equal to e. Cool? All righty. Ladies and gents, how do we go to log form? All righty. So I'm going to do each one of the different versions and make sure we're good. We're going to start with base stays base, the other two switch place. This is the base. So it's log base 6, and these other two switch place of 36 is equal to 2. All righty. Next one is loop de loop. So log base x loop de loop. Cool? All righty. Number 7, left right equals middle. So log base 9 3 is equal to 1/2. We all gravy? So, ladies and gentlemen, boys and girls, remember, it's how do you go from the base to the next number using exponents. That is what a log is trying to tell you. Now, this is super important when you think about things growing in exponential growth or exponential decay. That's why we need to know what logs are. So let's evaluate these without the use of a calculator. So there's a couple of different ways to do this. So since you guys tend to be very algebra centric, think of this as, well, how do I do this right here? We're going to say, what does that equal? That's what we're looking for. Log base 3 of 9 is what? So then the next thing, once you do, is convert it. So 3 to the x is equal to 9. Well, 3 to the what power is 9? 2. 3 squared is 9. Or, ladies and gentlemen, you just say to yourself, how do I go from 3, your base, to the number using exponents? 3 to the what? In this case, 3 squared. All right, let's go to the next one. 2 to the what gives you 16. 2 to the what power gives you 16? Again, that's going to be 2 to the 4th power is 16. So our answer here is 4. Now, if you want to do it the other way, as was mentioned first, we're going to set it equal to x. We're going to convert it to exponent form. Base stays base, the other two switch place. Loop de loop. Left to right equals middle. And then we still get x equals 4. Alrighty. I like the way I've been showing you just because it sort of really drives it in. Alrighty. So number 10, we said, hey, there's no base, so let's write in. So how do I go from 10 to 1,000? Well, think of it this way. 10 to the 1 is 10. 10 squared, 100. 10 cubed is 1,000. So my answer is 3. Alrighty. Now we're going to step it up a little smidge on number 11. This right here is 0.001. So remember, it goes tens, hundreds, thousands. So really, this is log base 10, because there's no base, of 1 out of 1,000. Alrighty. So let's go ahead and investigate what we got right here. So since we are in the 1,000th decimal place, I want to say, how do we make these work? Okay. Well, another way of thinking this is, how do I make them look very similar? Because right now, I'm not sure how to get to 10,000. Well, what if it was, just for a moment, just 1,000? Well, as we just mentioned in the previous example, that's 3. But it's 1 over 1,000. So how do I get to 1,000? Well, it needs to be 10 to the 3. That's going to give me 1,000. But how do I make it 1 over 1,000? Well, that's if we use our negative exponents. Negative exponents are going to flip, as we talked about in the previous video. So in this case, it's going to be negative 3. Okay? So, ladies and gentlemen, boys and girls, I want you to sort of notice some trends here before we get going too much further. If I'm going from a base to a bigger number, notice our value is bigger than 1. Base to a bigger number, it was a 4. Base to a bigger number, it's a 3. But when we're going to a smaller number, it's either going to be a fraction or a negative. Okay? Now, let's be very clear. This does not give us a negative answer. We're using our negative exponent rules. Okay? So, just one against to drive that in right here. I went from 16 to 4. That's getting smaller. It's 1/2 or a negative number. So, keep that in mind. All right, so let's look at this next one. So, I'm going from 25 to 5. So, the idea is, because I'm getting smaller, I can't just say that my number is going to be a whole counting number. It's going to be a fraction or a decimal. Okay? So, 25 to the what power is 5? Okay? Well, obviously, it's going to be not negative because we're not flipping anything. I'm just getting smaller. Well, let's think about this, ladies and gentlemen, boys and girls. 25 to the 1, 25. 25 squared, 625. So we're going in the wrong direction, as was mentioned. So let's try something else. 25 to the 1/2. Well, we mentioned that that's going to be a radical. So that's really the square root of 25, which is 5. So 1/2 is my answer. So x is going to be 1/2 in this example, or 1/2 is my value. Alrighty, this 3 log to the 1. Okay, so before we get too crazy, let's worry about the log, because that's what we're really looking at. Okay, so we'll worry about the 3 in just a second. Okay, so how do I go from 10 to 1 using our exponent rules? Now, this is a tricky one, because if I tried to do the square root, as we saw in the previous example, I'm going to get a decimal that's not even close to 1. If I do a cube root, I'm just getting smaller than that. So that's not helping me at all. So let's remember some important rules. What is 10 to the 1? 10. What's 10 to the 0? 1. Anything to the 0 power is 1. So if I'm going back over here and I want to go 10 to the 1, that's got to be 0. So that's a 0, and then the 3 comes down, so my answer is just 0. Alrighty, ladies and gentlemen, on our next one here, 14. We're going to split it up again. 2 log base e, because it's an ln, of e to the 3. Okay? So, ladies and gentlemen, this is a special instance because this is actually going to be like, hey, how do I do this? That's a 1, right? But ladies and gentlemen, to the third power means something special here, sports fans. This is what we're going to do, is we're going to have to add these together. Because this is one of our, it's called our power rule from exponents. So when we have a log to another power, that's like you're saying log e to the e, take that answer, plus log base e to the e, take that answer, and log base e to the e, take that and add it together. So as we just mentioned, wait, if we have this, how do we go to itself? That's a 1. So 1 plus 1 plus 1, which is 3. 2 times 3 is going to be 6. Cool? Now, that got a little confusing, so let me show you something else that's kind of easy. So hopefully you didn't move on to the next example already, because what I'm going to show you what's called the common base rule. Okay? So this is known as the common base rule. And what that says is the common base rule is anytime you have the same base, like what we have here, we have a 3 and a 3. Sorry, not a 3 and a 3, excuse me, an E and an E. Because those bases are the same, they're actually going to cancel out. And then this 3 is going to drop down. So it would be then just 2 times 3, which is 6. And we're going to talk more about that rule a little bit later. It's an important one to remember. So the common base rule is log base b of b to the a. If those are the same, they cancel out, drops. And it's really using the rule that I mentioned originally. All right, let's go to this next one. Log base 9 of 1 over 81. All righty, so how do I go from 9 to 81? Well, 9 to the 81 would be 9 squared, gives me 81. So how do I make it 1 over 81? To send this to the denominator, I need to make that negative. So that's 1 over 81. Excuse me, my answer would be negative 2. Got to fix that and make sure we're doing everything right. All righty. So let's look at this next one. So let's do it the X method. We haven't done that one in a second just to make sure we're good to review some stuff. So let's set that equal to X. So 25 to the X power is 1/5. Cool? Alrighty. Well, right now I could say, alrighty, so this is 25 to the X. Good to know. Well, isn't 25 5 squared? So can I write it like that? Sure. That's still 1/5. Well, how's another way to write 1/5? 5 to the negative 1. So this is 5 to the 2x is equal to 5 to the negative 1. And since these are the same, we can go ahead and say that 2x is equal to negative 1. So x would be a negative 1/2. Lots of rules going on, lots of different variations of way to do things. Make sure that you guys are feeling okay with this. Talk to your teachers if you need more explanations. There's plenty of different ways to do these examples. We're just hitting on some of them. And we got plenty more to do, so we're going to keep on cruising to the next one. Okay? And then, ladies and gentlemen, when we're all said and done, we're going to write down some information, and I'm going to give you 8 things that you should probably write down, but I'll let you decide. All right. So if we look, common base, 8 and 8, those are the same numbers, so they're going to cancel out. And so I'm going to have just a 2. Makes that a little bit easier. Let's look at that common base rule one more time. Log base 7 with the 7. They cancel out. X drops down. Hitting that common base really quickly. Now, this is another version of your common base where it's 3, and then all this log base 3 is also in your exponent. So that's a common base rule. It's just another version of our common base rule. But notice that they just keep matching. And so then this drops down and just going to be 9. Okay? Now, you could do that a couple of different ways. You can make it so that that's a 2, and then make it 3 squared. It's up to you. Alrighty, another common base, because remember, anytime we have a log, that's log base 10. So 10 log base 10 of 2 cancels out, and that's just 2. 10 log base 10 of x, common base rule, so my answer is just x. All righty. So, ladies and gentlemen, this is an important one here, and it goes back to another one of our log rules. So here we have log 2, and then what we'd really love is for this 2 not to be there, because then I could just make it x, right? Well, one of our rules for logs, known as the power rule, means that if you have something times a log, so if I have 2 times log, I can put this in front to make it x squared instead of just 2 times log. So I'm going to write this as 10 to the log base 10 of x squared. So now I have my common base rule. Those will cancel out, and I'm left with just x squared. Alrighty, ladies and gentlemen, keep on cruising. So e to the log base e of 2, common base rule, answer's just 2. E to the log base e of x, common base rule, answer's just x. Alrighty, once you hit pause on this one, see if you could tackle number 25. You're going to have to make it look like number 22, but just to see if you got it. Give it a shot. Alrighty, unpause hopefully. So I'm going to make this e to the log base e of x cubed. Common base, drop down. Cool? Easy peasy lemon squeezy. All right, 26, we have a add. So we really want to bring this in, okay? And I'm going to erase what we had above this because I'm going to say let's bring in PEMDAS. Helps if I spell, please excuse my dear Aunt Shaniqua, correctly. The E is what we're going to have to do first. So logs and exponents, that's where they need to go with our PEMDAS. So because I have this plus sign right here, I need to do that at the end. Okay, so it's almost like you're going to draw a line down, and I'm going to do this part, and then this part, okay? So, ladies and gents, I'm going to say, alrighty, how do I go from log base 10 to 1? Remember, anything to the 0 power is 1, so that's going to be like, boop, 0. Alrighty, so look at this. I have a common base right here with log 40s, so the j is going to fall down. But I got a 300 in front of that. So 300 times j is going to be 300j. So 0 plus 300j is just going to be 300j. So exponents. Do your log stuff first if you have any pluses or subtraction signs. Alrighty. So ladies and gents, 27 and 28 are when we're going to go back and we're going to do a common log or common base problem, very similar to what I did over here on 16. Okay, so what I'm going to do is another way to solve this is to make sure they have the same bases. Okay, so I'm going to convert this. 8 to the x is equal to 4. Get rid of that so it doesn't clog our screen. Well, there's no way you're thinking I can make 8 into a 4 using exponents. Well, there is a way, so let's use our common bases. So if I think of 4, 4 to the 1 is 4, 4 squared is 16. That's definitely not 8. So let's stay away from the 4s. Let's look at the 2s. 2 to the 1 is 2. 2 squared is 4. 2 cubed is 8. So I can rewrite this as 2 to the 3x, and the 4 is 2 squared. So now that they do have that common base, what I'm going to do is I'm going to set those exponents equal to each other. So 3x equals 2. So x is going to be 2/3. All right, let's go to the next one here. Set this equal to x. So 2/16 to the x is equal to 36. Well, you might be looking at 2/16 and going, I'm not sure what makes that. But I know 36 using my exponents is 6 squared. So what's 6 cubed then? Well, that happens to be 2/16. So 6 cubed times x is equal to 6 squared. So these have the same base. So we'll say 3x is equal to 2. So x is going to be 2/3. Now, just because these were both 2/3 doesn't mean that every answer that you don't know is 2/3. Okay? But what I do want to go back is I kind of want to just say, hey, we did all these in a bunch of different ways. And as you're looking at all this, you're like, I am so confused. The best way to do these log problems is to seriously practice and decide which way works for you. So we started with this first one saying, how do I go from 3 to 9, right? Using exponents. That's how we got our 2, because 3 squared is 2. Okay? On this next one, we said, hey, if I erase this, I could say, alrighty, that's equal to x, convert it to exponent form, and then basically do the same thing that we just got done doing. Saying 2 to the what power is 16. So 2 to the 1 is 2, 2 squared is 4, 2 to the third is 8, 2 to the fourth, 16. And again, that's why our answer was 4. Now, we had to remember a couple of things along the way, like radicals, had to remember a couple of things like negative exponents. And that's why at the bottom of the list, we're going to say, hey, let's write down everything that we need to know. Okay? But there's a couple of last minute things before I just say, hey, here's what you need to know. Go ahead and try this. Find out what works for you and move on. Cool? So, can you find the log of 0? So the answer to that question is using exponents, can you make 0? You can't. So no. Because when we did exponential growth just the other day, we said that this was my asymptote right there, which is x equals 0. We always had to go above that. We couldn't actually get there. So that's why we're going to say no. How about a negative? Well, a negative would be down here. How did we get down here? You couldn't unless you multiplied it by a negative number. So that's another one you can't do. Nope. Okay? So, to explain, and here's the kicker, one of the things you need to know. Okay? So, there's no zeros. Okay? Because you can't make zeros. Because even x to the 0 is 1. And there's no negatives. Now, ladies and gents, some of you are like, well, wait a minute, you just did a negative. My answer can be negative, but I can't take the log of a negative number. Okay? So, ladies and gentlemen, let's write down all the stuff that we need to know. Okay? And then practice, practice, practice. The first thing is how you convert. Always decide how you convert. That goes back to same base, the other two switch place, loop-de-loop, or left to right equals the middle. Okay? But the idea is log base b of a, you can go both ways, okay? Sorry, I should say of y is the same as, you can go both ways, as b to the y is equal to a. That's the first thing you need to know, is that converting piece. The second thing that you want to know is that common base rule. Where you would go ahead and say, alrighty, if it's log base a of a, that's going to cancel out. And then whatever's up here is going to drop down. Or it could be b to the log base x. Oh, x to the log base x, same thing. and then whatever's right there will drop down. So those are the first two most important things. So after this, it really is writing down what you need. Now, if we were to write down everything, I would go log is the same thing as log base 10. But if you don't need that, you can remember that, don't write it down. But I'm going to write it down just so we have everything. If you're going to have ln, that's the same thing as log base e. If you can remember that, you're good to go. Okay? The other thing that I would write down, again, if you got it, then don't worry about it, is that you can't take the log of 0 or negatives, as we mentioned up top. But if you can remember that, then you're a rock star. You do your thing. Okay? But we're just going to keep on rolling down, and you write down what you think is important for you. All right, number 6. The other thing I wanted to say is if your log is getting larger, then you're thinking whole number. If your log is going to get smaller, I want you to think of negatives or fractions. Another thing I would write down, but again, you're writing down for stuff that you think, is that power rule that we talked about, is that if you have log of b base x, that's what we started with. If you have a number in front, then this can go and move to become log base b of x to the a. So you can move that number in front. We called it the power rule in Algebra 2. All right, and last but not least, it's the same. It's considered to be the exponent rule of equality, or property of equality. But that's if you have the same base, b to the x is equal to b to the y, then because your bases are the same, x equals y. So that's all the stuff that I would write down for stuff to remember. You could remember just 5 of them. You could remember just 2 of them. You're honor students. You get to decide. But that is the basis of converting and evaluating logs. See you next time.